friends, so here in this video we have to prove that cot theta minus cot 2 theta upon cot theta plus cot 2 theta is equal to sin theta upon sin 3 theta. Now to prove this result, if you will see, then on the left hand side we have more terms. So I always say, whenever we have proved that in trigonometry, always start from a side, or generally we start from a side which has maximum number of terms. So I am gonna start disprove that from left hand side. After that, the second observation is, on the left hand side we have trigonometric function as cot, whereas on right hand side we have trigonometric function as sine. So whenever we have different trigonometric functions on both sides, that time we convert all the trigonometric functions in terms of sine and cos, and then we solve the problem. So it means, if I am starting from left hand side, then on left hand side I have function as cot, so I will convert it into sine and cos, and after that we will do the simplification, some mathematical adjustments, and we will prove that it is equal to sin theta into sin 3 theta. So let's start, my friend. So therefore LHS is equal to cot theta minus cot of 2 theta upon cot theta plus cot of 2 theta. So now let's convert cot in terms of sine and cos. So cot theta is nothing but cos theta upon sine theta, minus cot 2 theta is cos of 2 theta upon sine of 2 theta. Similarly in the denominator, so now we converted all the terms in terms of sine and cos. Now let's solve it, or let's simplify it. So what I'll do is, in the numerator I can take LCM. So I'll multiply these two terms crosswise and denominator. So we will get cos theta into sin 2 theta, or I'll write sin 2 theta into cos theta minus cos 2 theta into sin theta whole upon sin theta into sin 2 theta upon, similarly I'll do in the denominator. So we will get sin of 2 theta into cos theta plus cos of 2 theta into sin theta upon sin theta into sin of 2 theta. Now guys, if you will observe carefully, then we can cancel the denominator from both the terms. And now for the remaining term we can apply the formula. So here if you will observe carefully, then the angle is same. So 2 theta, here I have 2 theta. Once this 2 theta is with sine and once it is with cos, then we have angle theta, once it is with cos and once it is with sine. So it is reminding me about one formula, and that formula is nothing but sine of A minus B, which is sine A into cos of B minus cos of A into sine of B. So in this formula we have angle A and B. So A is written once with sine, then with cos, and similarly B is written with cos and sine with negative sign in between, and I am getting the similar format over here. So I can say that A is with sine in the first term. So here my A will be 2 theta, because with sine I have 2 theta. So I can consider this 2 theta as A. So this can become my A, and I can say that this theta is nothing but my B. So by applying this formula we can say that the value here is sine of 2 theta, that is A, minus B, that is theta, upon, now in the denominator we have the same pattern. So 2 theta is with sine and then with cos, and then theta is with cos and sine. The only difference is the middle sign is positive. So guys, we can apply the same formula That means whenever we have plus sign in between, then in the formula or in the value we get the plus sign. So here I can say that 2 theta is my A and theta is my B. So I'll get sine of 2 theta plus theta. And if we'll simplify this, then we will get sine of 2 theta minus theta, that is theta, upon sine of 2 theta plus theta, that is 3 theta. And guys, here we got our required right hand side. So we have seen here that how to prove the two sides having different trigonometric functions by converting the functions in terms of sine and cos, and then by doing the simplification. Thank you.